Charlie. Okay, so we start this next chapter today on equations and inequalities, and we'll be using some of the same stuff that we learned about in polynomials as we go through this chapter. So, we're going to look at solving equations. And solving an equation, what it means, you're going to be giving an equation, and there's going to be an unknown component to that equation, a variable, a letter. And you want to find the value of the variable, what number do you need to put in there in order to make the equation true? And we call that solving the equation. So in this warm-up, as a introduction, it says determine the missing number that would make the equation or make a true statement for each of the following. For the first one, what number plus 4 will equal 5? And obviously the answer is 1. 1 plus 4 equals 5. As an equation, instead of a blank there, that would look like this. X plus 4 equals 5. That's asking what number plus 4 will equal 5. So that's what it would look like as an equation. The second one, what number take away 6 will equal 2? And the answer would be 8. 8 take away 6 is 2. As an equation, that would look like something like this. Any letter can be used to represent the number you're looking for. So in this case, I said, what about using the letter y? Y minus 6 equals 2 is asking, what number take away 6 equals 2? The next one, what number plus 6 equals negative 2? So requires a little bit more thought. The answer to that would be negative 8. Negative 8 plus 6 does equal negative 2. As an equation, it might look something like z plus 6 equals negative 2. And the point would be to find the value of z that would make that correct. Number 4, 7 take away what number is 10? The answer to that is negative 3, because the minus minus becomes a plus positive, Danny. Put your phone away. So again, as an equation, it may look like 7 take away b equals 10. And the point would be to find the value of b that makes that equation true. So some of the simple ones, you can look at it. In many cases, you know what the answer is just by applying a little bit of simple logic. But we're going to go through some mathematical steps that we can use to solve all these types of equations. So what you're going to want to do in each case, whatever the variable is, whatever letter is used for the variable, you want to get it by itself. We're going to use some mathematical steps to get the variable by itself. Okay? So we do this by doing the opposite operation. What we do to one side of the equation, we must do the same thing to the other side. The goal, here's your booklet. The goal is to isolate the variable or solve for the unknown. So we can always confirm our solutions are correct by checking our answer. This can be done by substituting the answer back into the original equation to see if it works out. So this first one, it says algebraically solve the following equations and then check the answer. So when it says algebraically solve, it means show what steps you did to get the letter, the variable, by itself. So this first one says x minus 6 equals 10. Now again, you might look at that and say, well, I know the answer is 16. 16 minus 6 equals 10. That's true. But what can we do algebraically to get the letter x by itself? So what you have to look and see is what's hooked onto the x and how is it hooked onto it. Hooked onto the x is a 6 by subtraction. To get rid of the 6, we do the opposite of subtracting 6, which is adding 6. And whatever you do to one side, you must do the same thing to the other. So you're going to add 6 to both sides. The point of doing this, on the left side, minus 6 plus 6 cancels. So you're just left with x on the left. And on the right side, 10 plus 6 is 16. You okay, Christy? You allergic to Lena all of a sudden, or what? Okay, so there's the answer. We said before we know what the answer is going to be, but now we see how we can apply some mathematical steps to determine it. And then it says to verify. So here's what the verification looks like. You start with the original equation. X take away 6 must equal 10. So the equal sign divides the equation up into two sides, the left side and the right side, on either side of the equal sign. On the right side, we have an answer of 10. We must show that we'll get the same answer on the left side when we let x equal 16. And we do. You should never get these wrong because you can always check them to make sure that the answer that you came up with does work. So there's the answer. Question B. We want to get the letter y by itself. So you got to look and see what's hooked onto the y and how. Hooked onto the y is a 4, and it's hooked on there by subtraction. The opposite of subtracting 4 is adding 4. So we're going to add a 4 to the left because we want to get the letter y by itself. But whatever we do to the left side, we have to do the same thing to the other side. So we're adding 4 to both sides. And on the left side, the reason we added 4 to both sides is the negative 4 plus 4 cancels. You're left with the letter y on the left. And on the right side, negative 9 plus 4, well, that's negative 5. And again, I said this before, if you need to use your calculator to help you get some of these answers involving integers, then you should use your calculator. Go negative 9 plus 4 in your calculator, and you'll get the answer of negative 5. To verify it, we start with the original equation. Again, the equal sign divides it up into two sides, left side and right side. We've got a negative 9 on the right side. We need to show that we'll also get negative 9 on the left when we sub our answer for y in to the equation. And negative 5 take away 4 is negative 9. So there's our check. We've shown that our answer is correct. Right? So in each case, we've shown that our answer is correct. Again, you should never get these wrong because you can always check them to make sure. Looking at question C. You've got the letter Z you need to get by itself. Hooked onto the Z is a negative 16. Okay? So there is a plus sign in between the negative 16 and the Z, but you still need to get rid of the negative 16. And the opposite of negative 16 is positive 16. So we're going to add 16 to both sides. We need to get the letter Z by itself. And the reason this works is because on the left side, negative 16 plus 16 cancels. You've got Z by itself. And on the right side, 7 plus 16 is 23. So now we're going to check it. Make sure. Again, the equal sign divides it up into two sides, left and right. The right side is 7. We need to show that we get 7 on the left side as well. So we'll have negative 16 plus 23 on the left, which does equal 7. And again, if you need to use your calculator to do this, do it. Negative 16 plus 23 does equal 7. Okay, question D. That equation says 3 take away x equals 17. So that 3 is a positive 3. There's a sign in front of the x, which is a negative x. We want to know what positive x equals, not negative x. So there's a couple different ways we can do this, but one of them is to make the x go from a negative x to a positive x, and we can do that by adding x to both sides. So we don't always just have to move numbers. We don't always have to add and subtract numbers to both sides. We can do the same thing with variables. Because the point is, we don't want to know what negative x equals. We want to know what positive x equals. So what happens on the left is the minus x plus x cancel. And you've got positive 3 on the left equaling 17 plus x on the right. but we still don't have positive x by itself. So now we have to do one more step, and that is to subtract 17 from both sides. Because on the right side, the x and the 17 are hooked together by a plus. It's a positive 17. So what happens is that the 17 minus 17 on the right side cancel. On the left side, we've got 3 take away 17, which is negative 14, equals, on the right side, we just have x by itself, and there's our answer. Our answer is negative 14. So when we check it, again, you start with the original equation. The equal sign divides it up into two sides, left and right. The left side is 3 take away x, and we found x to be negative 14. The minus minus becomes a plus positive. 3 plus 14 is 17. We've got the same thing on both sides. So we've just shown that our answer is correct. In both cases, we verified our answer. Again, you should never get these wrong because you can always check them. It doesn't matter if the number is an integer or a decimal. It doesn't change the way it's done. So for question E, we need to get the positive y by itself. Hooked onto the y is a 1.3, and it's a plus 1.3. So we'll subtract 1.3 from both sides. So on the left side, the 1.3 take away 1.3 cancels. We'll have the letter y by itself on the left. On the right side, 2.7 take away 1.3 is 1.4. So that's our answer. That's the number we have to use in our check. On the left side, we have 1.3 plus 1.4, which is 2.7. So it checks. You get the same thing on both sides. Shows that our answer is correct. It is the answer that makes the equation true. Okay, try F on your own. So we need to get the letter Z by itself. Hooked onto the Z is a 5 by subtraction. It's Z minus 5. The opposite of subtracting 5 is adding 5, which we do to both sides. So on the left, minus 5 plus 5 cancels. You're left with Z by itself, and on the right, negative 13 plus 5 is negative 8. So there's our answer that we're going to use in our check. The equal sign divides it up into two sides, the left and the right. The right side is negative 13. The left side, Z take away 5. The Z's replaced with negative 8. And negative 8 take away 5 is negative 13. There you go, Stanley. Did you sign in? So we've just shown that our answer is correct. It checks. It is the value of Z that makes the equation true. Question G. We saw one like this earlier. We don't want to know what negative A equals. We want to know what positive A equals. So that's going to be my first step. I'm going to add A to both sides so that the A is positive, not negative. Now there is another way that we can handle this, and we'll get into that. But for now, this is how I'm going to do it. So on the left side, minus A plus A cancels. We're left with 5.4 on the left, and on the right side, it's 9.8 plus A. And so we'll subtract the 9.8 from both sides. And so on the left side, we have 5.4, take away 9.8, which is negative 4.4. So there's our answer. And that's the number that we're going to use in our check. So on the left, it's 5.4, take away negative 4.4. Again, the minus minus becomes a plus positive, and it's 5.4 plus 4.4, which is 9.8. So it checks. We've just shown that our solution is correct. It works. Now, question H is a different kind because the x and the 5 are now hooked together by division. It's x divided by 5. So to get the x by itself, we do the opposite of dividing by 5, which is multiplying by 5. So I'm going to multiply both sides by 5. And on the left, you've got 5x divided by 5. 5 divided by 5 is 1. So you'll get 1x or just x. Essentially, the 5's cancel. And you'll just have x on the left. On the right, negative 3 times 5 is negative 15. So there's the answer. And that's the number that we need to put in our check. So on the right side, we have negative 3. On the left, it's negative 15 divided by 5, which is negative 3. It checks. We've just shown that our answer is correct. For question I, the negative 5.2 and the x, the negative 5.2 and the x are hooked together by multiplication. It's negative 5.2 times x. So the opposite of multiplying by negative 5.2 is dividing by negative 5.2. We look and see what's hooked onto the variable and how it's hooked on there. And we do the opposite. The negative 5.2 and the x are hooked together by multiplication. The opposite of multiplying by negative 5.2 is dividing by negative 5.2. When you divide negative 5.2 by itself, they cancel. You'll get 1. 1x, or just x, equals. And we're for sure going to need our calculator on this one. Don't forget about the negative sign. You're dividing by negative 5.2. The answer is negative 1.3. So that's our answer. And to check it, always start with the original equation. We have negative 5.2 times negative 1.3, which we'll use our calculator to check. Get the same answer on both sides. So it checks. Right? Try question J on your own.
What? What are you doing?
Leave her alone. She wants to do her work. Looks like she wants a sugar high. What'd you do there, Keen? What'd you do for question J? You subtract 5.1 from both sides. You want to go double or nothing on the pop you already owe me that you're probably never going to pay? Jan,
You multiply 5.1.
so you're saying that Keen is full of crap.
Yes.
Good call. Keen is full of crap. Explain to Keen why you multiply both sides by 5.1. Because the x and the 5.1 are hooked together by division. It's okay to say that Princess told you that's how you did it. It's okay to say that. What? Good job. See, Keen, you should be more like Princess and Jan. Okay, so those are hooked together by division, so we do the opposite, which is multiply both sides by 5.1. And the reason this works is because on the left, 5.1 divided by 5.1 is 1. When you divide something by itself, you'll get 1. 1x, or just x, equals. On the right side, 4.3 times 5.1. Is 21.93. That's the answer that we get. And so that's the number you need to put in your check. And Keen, if you would have checked it, you would have seen that you didn't get the right answer. If you subtract 5.1 from both sides and you put that number in to the equation to check it, it wouldn't have worked. And then you would have asked either Jan or Princess, okay, how do I do this? I don't know what I'm doing. And they would have said, never mind, figure it out yourself. So on the left, it's x, which we found to be 21.93. That's divided by 5.1. And we should get the same thing that's on the right side. We should get the 4.3. And we do. Should never get these wrong, because you can always check them to make sure that the answer that you got works. It is the value that makes the equation true. Okay? Okay, I'll hand out the assignment. Now, once again,